Hi, in this video we're going to learn how to find our way around in the CNC simulation environment. So how do we get to this environment? Let's start from the beginning. We'll close this. And we're going to start by double clicking our MTS Stop Start icon, which brings us to our home screen. We select the machining we want to do, turning or milling. I'm going to work in milling. We select our machine. I'm going to stick with the Haas VF2SS UTC controlled machine. Verify that it's the machine that I'm looking for, and I'm going to be simulating the MTS mill part. So I select that part and I click Simulator to take me into the simulation environment. So when we get into the simulation environment, it's in automatic mode but in single block and waiting on us to go from there. If I want to see different view of the machine, I want to be able to rotate that machine, I just left click and hold that button down, and that allows me to rotate. We term it as rotate the camera around the machine. Machines are a little too heavy to be flipping around like this, so we're moving our perspective around the machine. If I want to change the position by which the machine rotates, I just double click somewhere on the machine. I'll say up here at this emblem. And now as I rotate, it's rotating about that point. If I want to rotate about another point, let's say maybe the magazine, the tool magazine, I'm going to double click there and that becomes my center of rotation. Or if I like rotating about the workpiece, I double click in that area and I'm rotating about the workpiece. To zoom in and out, I can just roll the center scroll button of my mouse in and out to zoom. And if I want to pan left and right, I can hold the center button down in order to pan left and right. Along the top, these icons along the top, if we look at the magnifying glasses, if I should happen to lose my machine, I somehow get it off in space somewhere, this first magnifying glass, reset camera. You'll notice as you hover over these icons, they tell you what the icon is. Reset camera brings my camera back into front of the machine into perspective. The plus and minus, zoom plus or minus the machine. In the rectangle, the zoom rectangle, when I select that, allows me to left click and hold, drag, and then release the left click button, and it'll zoom to the rectangle that I created. If I do it again, I can zoom to another rectangle. Now remember, as long as that is selected, I'm in my zoom, so if I want to get back to the regular mouse, I have to deselect that button, and now I'm back to just regular mouse function. That allows us to get good perspective of the machine. And then if I want to see some details, if I want to be able to see a little bit cleaner, first if I want the door open or shut, I go to the machine menu, open or close door. Here I'm going to close the door and the machine doors are closed. Open door will open the doors. Unlike in real life, our simulator will run with the doors closed or open, or with sheet metal completely out of the way. Here, if I say less details, you see more details is grayed out. There's no more detail to be added to this machine. Less details takes detail away, so I can strip away the sheet metal. Show any level of detail that I choose. Let's get rid of some of that sheet metal. And then working across, if I want to see the actual workpiece that I'm cutting, such as I have right now, I can select that. If I zoom in on the workpiece, we can see it in a little more detail. This is the workpiece that I'm working with. If I've attached a reference workpiece to this simulation, then I can compare to my reference workpiece and see the surplus material. So anything in blue is material I still have to cut out. I can see workpiece damage, so if I've cut into my reference workpiece and it shows as damage, if I have an error in programming and we overcut, we'll show that as red damage. Or I can see my reference workpiece. This is my target. This is what I'm looking to cut. Now to run our simulation, I'm going to deselect single block and press cycle start. Now it's running my part. And let me move out of your way, and I'm going to click feed hold. and I'm going to hold right there with feed hold. We're going to skip clipping for right now. And we're going to look at the Workpiece Features. When I click Workpiece Features, it puts a black line at the edge of each of my features. When I'm doing a part such as this one, where I want to see the engraving a little better, that's helpful to be able to see the engraving. If the part has a lot of detail or it has 3D surfacing or something like that, sometimes that can be a little distracting. So depending on what you're cutting, you can add black edges to the edges of your part, or you can take them away. The next one over is the paint brushes, so let's show the actual workpiece. Colorized workpiece allows the workpiece to be colored based on the tool's paint setting. So if I look at my tools, click the tools button, each of my tools can be set to show its cut in a certain color, so that makes it easier for us to see what tool has done what. Here I've got purple, green, and red for my face mill, end mill, and spot drill. So as I run the part, I see the end mill is cutting green, the face mill cut purple, and when the spot drill comes in to do the engraving, it will cut in a red color. If I feed hold that, if I deselect that, then it just shows my workpiece in the native raw material that I picked for my workpiece. We've already talked about the more details and left details. The coordinate system allows us to toggle between having the XYZ triad turned on and off. That will show up wherever your active workpiece coordinate system is. We're using G54 in this. G54 is set to the top front left corner of the workpiece, so that's where as soon as I read G54 in the program, the beginning of my program, G54, then it shows that icon wherever G54 is located. Sometimes we need to see a little detail or something fine underneath where that icon is located, so we can just get it out of our way, shut it off. The toolpath turns on the toolpath, and now we can see, similar to the BackPlot function that some visualization softwares have. And you notice when I click BackPlot, then I see my options for BackPlot. I can shut off tools. I can select or deselect whatever I want to, and we can also deselect any rapid movement, straight line movement, and arced movement as well, and only see the movement that we're looking for. We can also scan through our program and show the movement on each line of program. So if we're trying to isolate a certain piece of the program, this helps us to isolate a piece of the program. Now you notice that my position in my technology screen, or my controller screen, has gone away. These arrows to the lower right hand corner allow us to toggle through those different screens. Just going back to the left takes me back to that screen. I can go to the toolpath screen at any time. I can go to the section screen. When we look at how we section the workpiece, we can select different sections there. And we also have macro variables. We're one of the only softwares in the world that allows you to be able to read and see the macro variables that you're working with. The simulator fully supports macro B or macro variable programming. Now, as we're running this job, we don't want to watch the workpiece floating back and forth. Maybe it's a little bit distracting to have the workpiece moving, even though that's what would happen in real life on this particular machine. We can select some different places that we're going to view from. 2D we'll look at in a second. But I can lock the camera to the table itself, so now the machine shows as though the whole machine is sliding back and forth. Actually, our perspective is the camera's locked to the table. Or we can lock the camera to the workpiece in the table, in essence zooming in on the workpiece in itself. And we can also lock the camera to the active tool, so now we're following the tool. Or we can look at the workpiece itself. Now, as you can see, it's still being machined. We're still recognizing any collision with any of the rest of the CNC environment, but we're only looking at the workpiece, so we're not distracted by anything else. We've talked about 3D view or machine view. We also have a 2D view. You can access these different views also by right-clicking your mouse, and we have those same view options, or we can use the drop down. In 2D view, when we select 2D view, it takes us to a two-dimensional orthographic view. This is first angle projection, so we're looking at the front, left, and top view here. So when I reset and run this simulation, I see from orthographic perspective. Now here my clipping is turned on. So with my clipping turned on, I actually section the workpiece about the center line of the tool. We'll feed hold it and we'll zoom in. You can see in reality this end mill is buried inside of this material. If I turn clipping off, that's the way I see it. I see the end mill inside of the material. But if I want to see detail of what's going on actually in the material, I've basically sectioned that material in all three directions right about the center line of the spindle. So I can see what's going on. When I select that, I get options for different clipping options. Back to 3D view, and the next icon that we have is our collision detection. Collision detection right now you can see I have turned off. We should always leave collision detect on. That's what it's there for, to help clue us in when we have a collision. And we recognize a collision as pretty much anything that would be a collision in reality. If you engage in the workpiece with the spindle running the wrong direction or not running, or if you take too heavy a depth of cut and exceed the cutting edges of the cutting tool, come into contact with any of the work holding elements, G0 or rapid movement while in contact with the raw material, anything that in real life would be a collision, we recognize as a collision. And you know that, we'll look at it in a minute, the cutting tool and the thing that it collided with both light up as red. The next icon's over, optional stop, block skip, single block, maximum clock, background, restart, reset, feed hold and cycle start, match the buttons along the bottom. Let's go back over here, there we go. So if I want to, for instance, reset the program, I press reset. If I want to cycle start, green cycle start, and single block, there we go, cycle start. And that will start the program. Let's lock this guy to the workpiece. I can feed hold at any time. Cycle start, feed hold. And then this guy, previous block. Since this is a true CNC G-code simulator, meaning we're reading the lines of code, we can resize this window. We're on block number 120 right now, reading this movement. I can at any time go back one block and reread the previous block and cycle start from there. Feed hold, previous block, cycle start. So I can always go back one block, up to just one block. And I can resize this window if necessary. Background simulation we'll detail in a later video. The T, the test mode, enables max clock override. So what that means is when you depress the T or the max clock override, it runs a simulation as fast as your computer is capable of running it. You see it sets our clock override to maximum. With it deselected, we have a clock override set at 120% right now. The simulator has the same override buttons you would have on an actual CNC machine, the spindle and the feed rate override buttons, but we also have a clock override. So if I reset and I cycle start, 100% clock means we're traveling at real time. This is how fast we would see it actually run in the machine. We can turn that up. We can run it over 1,000, 3,000% of real time. If you have a 30-minute cycle on a part, you may not want to sit for 30 minutes and watch it simulate, so you can turn up time and move it along quicker. Now looking at the buttons along the left-hand side, we'll start with this guy, the start screen. The start screen is like our file management. Here we can create a new program, open an existing, save, print, import or export a program. If I want to open an existing program, it takes me into my program file. I can select any of the programs there that I've already set up. Our setup icon takes us into setup mode. So from here I can set my preparatory information. I can set my workpiece, whatever the workpiece is going to be. I can work on my clamping, select a vise, select a jaw chuck, go into modular clamping. We'll explore all the options for setup in another video. I can set my work offsets G54 through G59, and I can edit my magazine. From here I can go in and I can set the magazine of tools. On this machine is a 24 tool magazine, so I could set any of those 24 stations to what I want. In most of these windows we have an X or a green check. If you want to exit the window without saving any of the changes you may or may not have made, the red X. If you have made changes and you want to save those to the simulation, the green check. Next is MDI Jog. So when I go into the MDI Jog screen, now my MPG, my manual pulse generator or hand wheel, becomes active, and the simulator can work just like a real milling machine or turning center. I can select which axis, I can select the size of pulse or the increment of movement, and then move plus or minus in that direction. If I go more functions, turn the spindle on, I can then go ahead and mill my part manually if I choose. Collision detect in MDI or manual mode works just like it would in automatic mode. So here I had my spindle on the correct rotation. I was machining inside of Workpiece, so that's fine. But with collision detect turned on, if I come into contact with the work holding, then it's going to show that as a collision. My cutting tool and my vise jaw turned red, showing a collision. If I were to shut collision off, then I would be okay to move that right through the work holding. So we always like to work with collision detect on, so we alert ourselves to any machine collisions that we have. Also in MDI mode, we can do any key in any commands as we would in MDI. M05, enter, shuts our spindle. T02, M06, enter, and I put tool as you see here. Tool number 2 is now in the spindle. So we can execute MDI commands through our MDI mode. We click our drop down. We have a history of the MDI commands that we've used in this session. So if you have to revisit them, you can just select it and then enter to execute that code again. Automatic mode we visited already, but automatic mode puts us in the automatic. We can reset, we can cycle start, and we can run our simulation through the automatic mode. Edit takes us into our editor. Our editor is a very powerful editor. Not only does it have conditional formatting, so you see the different words and values in different colors, it does a syntax check. So if you use incorrect combination of codes and words, it shows you if you're in error. But it's also an interactive programming tool. When I click on a line of code or hover over a CNC word, it shows me what it is, G2, circular interpolation, and the clockwise. Information about what can be used with it and what it is. We can key in interactively information. We can the G codes that are available to be used with that particular code, or at any time we can add in or write in things in the editor. And we'll spend more time in the editor in later videos. The Tools button takes us again back into our magazine. We can view the tools in a 3-dimension, and we can move, zoom, pan, rotate just like we do in the simulation window. We can see the tools from any of the orthographic projections. I'm going to rotate it sideways so we can see the technology with the tool there a little clearer. Select any of the tools and it shows on screen. If I right click on the tool and I select extended view, I then see a broken down version of the tool assembly, the end mill to call it, the end mill hole, the collet chuck. And if I want to, I can select a different color for the tool by selecting Workpiece Color Selection, and I can choose any color that I want for that tool, and that'll paint that color. When I run that tool, that's the color that it will show. And I'm not going to save that. Close without saving the changes. Okay, we always alert if we've made changes and we're saving without changing, exiting without saving those changes. The Datum window shows me all my Datum settings. I'm only using G54 in this simulation, so I have my G54 X, Y, and Z. I don't have an offset for A, B, or C because I don't have those axes. During the setup process, I can attach drawings, so at any time we can open up the drawing and see the drawing of the part that we're making. We can attach not only workpiece drawings, but pretty much any document we want to attach. So in this guy, we've attached not only a workpiece drawing, but we've also attached a clamping drawing. Or we can go back to our workpiece drawing. And then the analysis button. If I go to my automatic mode, reset, and I run my program, we'll put it in maximum clock mode to get through it quickly, and then we look at our analysis. We now have an analysis of all the tools that have run. The face mill, the end mill, the spot drill, what its speeds and feeds were, how much time it ran in cut and how much time in rapid, how much raw material was removed. So if you're predicting tool life, if you want to evaluate for efficiency, there's a lot of great information there at the click of a button. We have a measure function, so we're now able to measure. You see this in an orthographic view again, and we can slice this part through different pieces of the part. If I switch in the window so you can see the part a little better. As I move these red and green and blue selections, which match the triad that we saw in there for X, Y, and Z, if I move those back and forth, I'm slicing that part, and I can take measurements about wherever I slice that part. If we switch that back, I can take measurements. What do I know about this line? What is this length? What do I know about this radius? What information do I have on this radius? We can go point to point. What is the distance from here to here? And it gives me angular information in all three sides of my triangle, from here to here. So we can measure pretty much anything we want to know on our workpiece. And this is not a measurement of a model, this is the measurement of the workpiece that was created based on the G-code and the cutting tools that you selected. And then finally we have options. Options allows us to customize the simulation environment. What unit of measure are we working in? What's the quality of the workpiece? If I go into automatic mode and I look at my workpiece, you can see there's a little fuzziness to some of the edges. I have it set at a medium quality. But if I increase the quality, then I see a nice sharp edges on that, a very clean model. It's a balance between what is the graphics of your computer able to do, speed-wise, and how clean a model do you want to see. Also in view, I can show my machine as transparent, so I have this ghost view. And I can adjust the level of transparency of the machine. And when we're done with our settings, we just X to get out of those settings. If we click down here, restore defaults, we'll restore our settings to the factory installed settings on the software. We have on the lower right hand corner in each of the screens a home button. If I press that home button, it takes me to a map similar to what we have on the left hand side, but now I can get to any of my options. I can go into the tool management from here. I can go into automatic mode from here. So the home button's a quick way to get me back to the master list of screens in the simulation software. contour editor takes us into a feature that's a very powerful feature that no other simulation software has. If I know a little bit of the geometry that I'm trying to create and I need the computer or the simulation software to help me with that geometry, I can go into the contour editor and I can create lines, arcs, whatever the case may be, whatever I need, and it will write that code for me. So we'll spend more time in another video, but I'm able to write CNC code, fill in the blank type information, and that will put it right into my program for me. So there's a reset, there we go, there's a quick start. Quick overview of the simulation software in the simulation environment. We have a lot more options to go, but that should get you up and simulating programs. So now have fun simulating the different programs, exploring the different features of the MTS simulation software. Thank you for your time, and we'll see you next time.